Pre-Calculus 2.4 to 2.5 test review. Problems 1 through 3 have you using synthetic division to divide the following. So remember, to use synthetic division, we're getting the coefficients from each of these polynomials. And then we're changing the sign of whatever we have over here. So those are all going to be negative ones outside of your synthetic division. Don't forget that if you are missing some terms, so like right here, I'm missing x to the fourth and x to the third, put zeros for those coefficients. And then we do synthetic division. Whatever we get is our remainder. Make sure you write your final answer as a polynomial. Examples 4 and 5, we're using the remainder theorem to find f of -2 and f of 2. If you don't use the remainder theorem, if you just plug -2 in for x, everywhere that you see an x, then you will not get credit for this on the test. So make sure you're using synthetic division and the remainder theorem. Problems 6 through 9, you're going to start by determining your end behavior. Then you're going to use synthetic division to determine if each of these factors is a factor of your function or not. Then I want you to find all of your zeros and determine if each zero bounces or crosses, depending on its multiplicity, and then graph each of these. This last problem is a lot like what you did in 6 through 9, just kind of spelled out a little bit more. So to start with, you're going to find your degree and your leading coefficient. Those are going to determine your end behavior. To find the y-intercept, we're just plugging 0 in for x. Then we're going to list all possible zeros. Remember, that's our p divided by q, and every possible combination of those with pluses and minuses. Next, you're going to use synthetic division to test those possible zeros. Always start with your smallest possible zero. I wouldn't do the fractions, but like start with 1 or start with -1 if that's an option, and then go to 1. If 1 and -1 aren't in your list, then start with -2 and then 2, whatever the smallest whole number is in your list. So test those. Find one of these that is a 0. Once you've got that, you can write your next factored form in a quadratic this time, since we have a cubic problem, and you can factor that quadratic. Once you have factored it all the way, you have your zeros. You're going to tell whether each of them cross or bounce, depending on the multiplicity, and then you're going to graph. Make sure you draw your x and your y axis. Put dots at your intercepts, both your x-intercepts and your y-intercept, and then make sure you have the correct end behavior in your graph. You are going to do great on your test. You've got this.